Hello everyone, welcome to the episode 62 of SoLeadSaturday. The guest we have today, Neelabh Pant. He is a senior data scientist at Walmart Technology DFW. He has a diverse skill set in computer science, data engineering, machine learning, artificial intelligence, and data science. He has worked in various business domains like oil and gas, home improvements, geospatial technology, and retail using time series analytics, forecasting techniques, and other state of art machine learning and AI methodologies. At Walmart Technology, Neelabh is focused on scaling the capabilities and impact of data science in a rapid growth retail environment and working towards digital transformation at Walmart. Neelabh graduated with Ph.D. in computer science, focused in spatial data analysis using machine learning and artificial intelligence, as well as has a master's in computer science from the University of Texas at Arlington. So let's just welcome him and hear more about his career journey. How did he find his area of interest and managing to lead that? So welcome Neelabh. Very happy to have you on the show and really appreciate all your time and consideration being on the show.
Absolutely, Vishali. Thank you so much for having me in the show.
Thank you so much. And moving towards our question segment, actually, the first section that we have is about passion and interest. So, how did you find your passion in the data science field, and what steps did you take to pursue this passion? Or I would just rephrase it like, what motivates you to be in this field?
Awesome. Yeah. So, talking about passion and data science, there are like a lot of points that I can actually talk about, and I can go for days to talk about just on this topic. But yes, there are like a couple of things that really excites me to be a part of data science and to be a data scientist, in my general life. So, first of all, data science just makes me very powerful for a lot of reasons. One of the things that I really truly believe in is that uh, the passion to achieve the discoveries, the insights, and even the innovation that is happening every day within machine learning and data science realm is just mind blowing, right? With any data set, as long as the data set is rich in quality, right? You actually can make very wise decision based on what the data is speaking to you, and since it's evolving every day so rapidly, right? So there's no point of getting even bored, just being in data science for so long, because now I know that my machine learning models are getting evolved, every day as it comes. So for example, if I'm working on a specific model in time series, like if I'm forecasting anything using a specific state of the art model, next thing you know, probably like in a month or two, you have a new technology just to to take care of that the same thing, probably in much more optimized fashion. So yeah, that just gives me pleasure of realizing that my work is getting evolved, every day, with data science. And it's just I would data science just helps everybody to make wiser decisions. It's not here to replace humans, right? It's actually here to work in synchrony with humans, getting the data, analyzing the big and huge data that you have, uh, just helps all of us to make wiser and optimized decisions. So those are the kind of things that really excites me, and I'm looking forward to the future of data science for sure.
Yep. Sounds good, and thank you so much for sharing. Moving towards our next section is about questions from the audience, where I shortlisted a couple of questions for you. So the first question under that segment is, what are the best models in machine learning to perform geospatial analysis, especially poverty mapping?
Okay. So if we just talk about, so poverty mapping is one of the things that you can do in GIS, right? Helps you in so many different ways to understand how different socioeconomic things are scattered across one special geography. So to develop such maps, you've got a lot of geostatistical tools out there, in the market. Things like ArcGIS is probably one of the leading company out there. It's actually built by Esri. So ArcGIS is a product that belongs to Esri, and that actually helps to build things like poverty maps, right? But there are another sophisticated methodologies to build something of that of that kind, things like deep learning, right? Making use of convolution neural networks, try to be as precise as possible without any human intervention and making things automated as long as you have enough data to train all these deep learning models for
Mhm.
them to understand what is the objective and making the wiser decision based on the historical data that they have seen. They can actually be utilized to make such maps. um, so yeah, so I mean, there are like many different ways to go about it.
Mhm.
As long as you know what your objective is in data science or in GIS per se,
Mhm.
I think based on that you can actually make better decisions as to if you want to take the tool side, or if you're like being ambitious and more fancy about developing some models to build something of that similar nature.
Yeah, so the way I understood is more like, if you are clear on your objective, what you are trying to solve, definitely that gives you the proper approach to uh,
Absolutely.
get that. Yeah. So thank you so much. Hope that answers the audience question. Next question is, what is the difference between? How would you like to differentiate between actually geostatical analysis and geospatial analysis?
Okay. So, geostatistical analysis is just a form of statistics that you perform over geospatial data. There are like many different things that you can actually perform. Things like interpolation. So, if you have a geographical data set, for example, if you have GPS coordinates, location history or trajectory history of any person, and you see there are like a couple of points missing, you can actually use geostatistics in order to interpolate those missing values. Long story short, any kind of statistics that you do over geospatial data, there is a class of statistics. It's called geostatistics, and within that class, you have a number of different algorithms and methods to go about solving whatever kind of problem is which is coming in front of you, which is based on the geospatial data. Now, if you talk about the geospatial analysis, that essentially is the analysis of the spatial data, right? Which is put over different layers of x and y coordinates. Now if you go about the concepts of different layers, and if you get into ArcGIS and learning more about geospatial, you will understand that a map is not just a plain two-dimensional figure. It's actually is a two-dimensional figure, but on top of that there are several different layers that go on top of them, right? There might be a layer that just shows the water bodies across one geography. There's another layer that actually shows roads on a specific geography. So, and there might be another layer that is just showing you the points, points like your house, my house, or a specific shop that you are wanting to go. So those are the different kind of data types that go over a special map, in form of layers. And these data points are called as geospatial data types, right? And they are basically of three basic natures: points, lines, and polygons. So these are the three different data types which you may not see in any other type of domain. And that is only seen in geospatial domain. So yeah, I mean, just geostatistics can actually be used to analyze the geospatial data, and that's how you can differentiate the
So
two.
definitely it is the area of specialization, right? It's like a very specific domain that you
Um,
can learn.
Yeah, I mean, my PhD was related to machine learning over geospatial data over spatial databases. There were a couple of different use cases that we figured out that can actually be solved with the mixture of these two pieces, which is GIS and machine learning. And we made some good use of all those technologies back in the days. And yeah, so that was all my PhD about.
GIS ARC is there, right? Something like that.
ArcGIS.
I just remembered that actually because in my academics, I remember that one of the group had that project on the geospatial analytics.
Right.
So so that is something quite interesting to learn as well. Actually, if students out there are looking for going into anything specific in a specific domain. So
Absolutely.
the next question is, what are some of common challenges and their solutions when designing or implementing geodatabase?
Yeah. So geodatabase is also known as spatial database, right? These are the databases which are exclusively made just to hold spatial data. Like I just talked about a couple of seconds ago, the different kind of data types that you see in spatial data are points, lines, and polygons. Hence, these different databases are actually optimized and engineered to hold such data. Now, with such database, like you said, there are like a lot of challenges, right? One of the challenges that I still remember during my PhD and masters was the indexing, of such databases. Now, if you look into any traditional state-of-the-art database, right, you will see a lot of indexing like B trees, B plus trees, right? So those are the kind of traditional indexing which are still used in a lot of databases to hold data, because the data sitting in those traditional databases are kind of integers, numbers, or strings, right, or characters. Here story changes just a little bit, where now we have vector, like the
Mm-hmm.
data is spread across a vector space, right? So we have strings of latitudes and longitudes that are representing all these different data types. If it is a polygon, the start is also going to be the end of the same job, or of the same geometry.
Mm-hmm.
Hence, for every point that we have for that polygon, we will have a pair of x and y coordinates, right? And as you increase the complexity of such data, by that I mean, if you try to get more heavy or richer data set, you will have more and heavy and richer sets of those coordinates. And now the challenge is how to store them
Mm-hmm.
first, and the second is how to access them, right? Because, for example, if you are using Google Maps, there are like billions of other users using Google Maps at the same time. And if you have to look for a specific location within your city, that location needs to be accessed using some sort of indexing methodology, and it needs to be in the real time because it's a
Mm-hmm.
service that everybody is using every time. So basic indexing methodologies like R trees, R plus trees, R star trees, those are the different variants of B plus and B trees, but a variant which is used in just spatial domain, right? And now within that, you also have other challenges like query optimization, right? So for example, if you want to look into the nearest neighbor queries, right? So you want to look into, uh, you know, restaurants near me, the most common query on Google, right? So it actually looks for the nearest neighbor around your location, right? And in order to do so, it has to go through a bunch of queries, right? And those bunch of queries just adds to the complexity, of complexity in the nature of execution. So indexing is definitely one of those big challenges, because there's like a lot of research still going on in terms of what query suits best for what indexing. So for example, if you just have one indexing, that does not mean that it's going to cater all your needs. There might be some queries that may get executed really fast using R trees, but there might be some other types of queries which are not meant for R trees, but they require some other special indexing, right? So query execution time, query optimization, comparison techniques between different indexing, and seeing which indexing works best for which query itself is a big challenge. And that was a part of my master's thesis as well.
Wow.
So yeah.
So I just have a curiosity, like, are there any specific algorithms that you always use for these particular cases? Specific
Like I said, indexing
reason is one
is
thing,
a
and then it's one.
is a is a task by itself. So you are never sure that if you just have one algorithm, let's say if you have
Uh,
one indexing methodology, you're never sure that this indexing is gonna cater or is just
mhm,
gonna support all types of queries with same performance.
mhm,
Then you have to realize that what are you gonna use the system for, right? Is it just gonna be for a specific use case, or is it just gonna be a generalized use case,
mhm.
right? Depending on what your use case is, you're gonna look into the right type of indexing, and this is just one part of the entire problem solving, right? And
Mhm.
there are like many other different things attached to it, but indexing definitely plays the most important role here.
Okay, okay, okay. Thank you so much. Definitely, that is insightful for the students as well, whoever asked the questions.
Mhm.
Moving towards our next segment is fun segment where I will give you three words and you have to come tell me, like, whatever comes to your mind. It can be like a short definition or like a keyword, replacement
Okay,
keyword for that particular thing. So are you ready?
sure.
Yeah. So the first word is academic research.
Definitely publications.
Wow.
uh, Definitely publications and conferences, and as much as you can contribute back to the society, right? The same society where took some help, right? Now it's time for you to actually provide it back to the society by doing some sort of novel research,
Mhm.
and anything that can actually be helpful for the community per se. that definitely is one thing that comes to my mind.
Okay, that's great. Second word is machine learning.
Love or live, I
Yeah,
think.
that's great.
Yeah,
Uh-huh.
yeah.
And then the third,
That is something that I have dedicated my rest of the life to.
okay, that's great. And that is a lot more popular as well, I feel. And then third word is data engineering.
Challenging.
Mm.
I truly have a deep respect for all the data engineers there. One of the big reasons is data engineer. If you look at the Venn diagram, right, and if you just have two circles, one is software engineering and one is machine learning,
Mhm,
that sweet spot, right, is where data engineering is actually sitting, right?
mhm,
There's another Venn diagram that you can actually make about the domain knowledge, but again, it may not be as much important as for data scientists, but definitely software engineering and machine learning is the combination of data engineers. And the
mhm,
biggest challenge is we expect them to definitely be really good with software engineering, but also we have this expectation of them being educated about machine learning. Not so
mhm.
much, but enough for them to understand that what's going on in the data science field.
Yeah,
So definitely a huge respect for data engineers, and it definitely is a challenging role.
yeah, that is definitely like I can also agree on that point because I did one academic project actually, and
Yeah,
I remember the struggles that we had to create the
absolutely. Yeah,
pipeline and data streamline. So definitely that is challenging. So
yeah.
thank you so much. And moving towards our next section is about exploring your career, work, and volunteering. So the first question under that segment is, through your experience being a data scientist, how do you see importance of a domain and how difficult or challenging it is to learn a new domain considering your technical expertise?
So whenever we talk about domain knowledge, right, by the definition of it, it really is the understanding of the environment where the data is actually getting processed and is getting accessed, right? Um, so, for example, at my job, you know, we work on different domains every time, right? And whenever we are about to start a project, the most important thing, at least for me and my team, is to really understand and deep dive into the domain knowledge of the project itself. Because what I personally think is your half battle is already won. Like you've already won your half battle if you really know what the domain is all about. By that I mean if you really know what you're gonna do with this data, right?
Uh-huh,
That leads to a lot of good things. One of the things that I have personally seen people having good domain knowledge happens to make better accurate models.
uh-huh,
Because the kind of knowledge that they have about all the different features given in the data set is just great, because sometimes you may not have data dictionary available to you, right?
uh-huh,
And most of the times it really the project really relies on somebody who really has good insight about the entire domain.
uh-huh,
So by making good models, I mean they may have an edge over how to engineer these features better, right? So you may have a list of 100 features, 100 sparse features, right? But you still cannot make use of them because it's sparse in nature. It's heavy in terms of processing. But
uh-huh,
a person who really understands the domain can actually engineer those features into small sets of say 5 to 10 features that are most important and really reflects what those 100 sparse features couldn't reflect. And the other thing is you really can actually harness the power of algorithms if you really understand the domain well. By that I mean there were cases when we were just in confusion as to what kind of algorithms or what kind of even solution path should we be taking to solve this kind of problem. And then later on we realized that we did not need any model per se, right? All we needed was to plot the entire distribution over 2 dimension and see if the distribution is following a similar pattern over the period of time, right? We understood it better because there were people, smart people in our team that actually helped us to understand the domain better, right? Just by looking at the distribution, we did not even have to make models. Instead, we could just have predicted because the distribution was very much stable. It had a good the seasonality attached to that, and the trend was pretty much stable over the period of time.
uh-huh.
So definitely we did not have to waste resources in terms of working over the models because the data was there. We had the good domain knowledge in our back pockets, and we just made use of the raw data and the knowledge that we acquired over the period of time.
Yeah. Thank you. And the next question is Would you like to share more, any interesting case study or the research use case from your experience with the audience?
Um, so one of the case studies that I was a part of, actually was also a part of my PhD, was about GPS trajectory forecasting. This is still a very interesting use case to me because I don't see a lot of work done from that side, where you have a set of historical GPS coordinates associated with a person's living style, and ultimately you're trying to build a model to see what kind of patterns and behaviors does this user follow in his day-to-day lives,
Mhm.
and if there is a way where we can actually forecast where this user is going to be next in his future, such that we can make use of that knowledge in terms of recommending him better products based on wherever he is located at the moment, helping him to get over severe calamities that were unknown before, but we now can forecast where this user is going to be in next future. We can actually make better decisions in terms of, I don't know, medical insurance, and recommendation in terms of retails, or just giving coupons or advertising your stuff, as the person is going through his trajectory, right?
Uh-huh.
So there you have machine learning in place, there you have spatial data in place, there you have domain knowledge about that special geography in place, and then there you have just interesting insights about a person's trajectory, or the way the person travels in his day-to-day life.
Yep, yep. Thank you so much. And moving towards our next section is about the tips and advice. You can support your answer with the specific books or the courses to the audience. So, any tips or advice would you like to give to the students or the professionals who wants to pursue their passion in this specific field or looking this field as their long-term career option?
Right. So the way I look at it is, I would always advise anybody getting in data science or is already a data scientist to try to think of data science. And again, this is just my point of view. Again, it may be subjective. But the way I look at it is, I look at it as a T-shaped model, right? Where the horizontal bar represents your knowledge about most of the things in data science, right? So you are well versed in most of the things, but
Mhm.
you tend to go a rabbit hole in just one piece of that entire stretch, right? So what I mean by that is, you have traditional machine learning and predictive analytics in data science, you have natural language processing, you have time series, you have computer vision, you have whatnot, right? You have OCR, you have RPA, or you have automation, so many things. Again, I do not expect anybody to be amazing in all those different domains, right? Because I truly believe that one should always, channelize his or her energy towards one thing,
Mhm.
while maintaining, decently acquired knowledge across the entire board. So for me, that rabbit hole, again, I'm not very deep in that. I'm still trying to, make my way around it. But my rabbit hole is time series. So I love time series for a lot of reasons, and that just kept me going on and learning more about it. So I would say that it's always a great practice to start with the traditional state of the art machine learning, what data science is all about, having a good knowledge about, supervised, unsupervised, reinforcement learning, just so that you know what it is. And then gradually over the period of time, just try to find your interest that you're most interested in. It may just be EDA, right? Because
Yeah.
that itself is a very important part of data science. It's the starting of a great project. So it may be EDA, right? For somebody else, it may be traditional predictive methodologies within data science realm, or
Mhm.
it could be somebody like me who wanted to go in just time series while maintaining his knowledge over across different domains, or it could be somebody else who loves to work in NLP, and his or her expertise and specialty is in NLP. So
Mhm.
I would always suggest that begin with the basic knowledge and try to advance it, by taking one domain and trying to be, and I think, an expert in that field.
Yep, yep. I think that is definitely something that students need to learn while learning because it is more or like exploration of data science field. It is very vast and very big, and it is, as he mentioned already, it is evolving. So this
Hmm.
is definitely is useful advice anybody to have. Moving towards our next section is ending segment of this particular show, which is leadership. So you are truly leading your area of interest, and what is your leadership style, and any specific leader that you always follow or admire, and why?
Sure. The way I look at it is I always suggest and talk to my juniors in terms of how to organize different works that they have been doing. One of the things that we all tend to do well is not organizing our notebooks. And there are like a lot of jokes and memes around such things, right? So you try to make a notebook that's untitled, another notebook, untitled underscore two, another one, untitled final, whatever. So what I'm trying to get to is it's really a good practice to have an organized way of performing whatever things that you're performing. And as a leader, I always suggest this point, but I also give the autonomy to my juniors, right? Because now is the stage when you cannot be micromanaging, right? And
Yes.
I personally don't like that, right? And I personally believe that people do fly with bright colors once you give them some sort of independence and
Mm-hmm.
certain level of autonomy, right? And they just do wonders, right? Wonders that you cannot even imagine of. So I think having those two things in place, and like the autonomy is really important for me. And when
Uh-huh.
we talk about role models in terms of leadership, for me, role models in leadership are people with whom I've worked closely. And one of the guys that really stands out is his name is Michael. He's actually my tech lead. So I really look up to him, right, and look at his style of leading, an entire team. And I think he has a similar work style that I love to do, and he's really great whenever it comes to giving the autonomy to his juniors and letting the juniors decide what solution does this project requires and how we even gonna begin with analyzing this set of data. So having that thing in place actually just give people a lot of independence and pleasure to work.
Yep, yep, yep. And this is like a very, really very good like leadership style to have, providing that independence as well as giving them the freedom to learn and explore by themselves first. And if they need any help, it is like showing by example, like
Absolutely.
doing it rather than just commenting or because sometimes people don't take the feedbacks for positively. So it's more over
Hmm.
like showing it from your work definitely helps
Hmm.
them. As you mentioned, right? You always follow your leader, whichever you are looking to. So it is
Hmm.
always like that way it happens automatically when that leader inspires you some other way and you
Hmm.
automatically start following and see yourself as that kind of a leader. So thank you
Absolutely.
so much for sharing. And the way I understood you, actually, I'm going to end it with a quote, which is like an investment in knowledge pays the best interest. The quote by Benjamin Franklin. And on that quote, we are going to end this show. And hope audience, you are going to enjoy it. As I always say, until we meet, happy leading. Let's live together. Stay safe. Bye for now.
Thanks, Vishali.